My name is Truls. I'm here to talk about automating security monitoring. Just to make sure that no one gets upset because this isn't what they thought it would be, we are going to talk about automating security monitoring. So this is going to be whenever we get security incidents or security alerts, what we can do with them automatically. It's going to be some base level of going through what security monitoring is and what automation is, and then obviously putting those two things together. So if you thought it was going to be something like infrastructure as code or something like that, I don't blame you for being upset and walking out. That's more than fine. Why are we talking about this now? Is automation, because automation has been around for quite a while, and so has security monitoring. And in the day of an age of AI, can't we just throw Copilot at everything and make it go away? Do we need automation? And sure, Copilot and tools like that is very good at what they do, but that's personal assistant type of work, where this is more going to be, we're going to be talking more about event-driven automation today. Someone is moving something. Yeah, we're going to be talking more about event-driven automation. Some of it might be started by a human, but we want to avoid, I was going to say avoid human interaction, but avoid having to remember to trigger a task. During the slide set, you might be wondering why are there so many slides, and there's a reason for this. I'm born somewhere around here at the edge of being a millennial, and so I'm something they call a sillennial. So for those of you who have been on Instagram or YouTube Shorts lately, you know my attention span is longer than one TikTok reel, but not very much longer. So I like to have what I'm talking about up on the slide deck so I don't go off on a tangent. So this is why there are a bunch of slides. Some of you might be wondering, who are you? And I'll tell you because I'm pretty sure no one knows, but my name is Truls, as I said. I'm local here in Oslo. I work as a security architect at a company called Soprasteria. I work in a security operations center. I have been doing that for the last 4 years. I'm a Microsoft MVP in security, and the thing I'm most proud of is that I'm the leader of the esports social group in my company. I also made the mistake of buying Baldur's Gate this year, so this conference is my first time outside for more than 20 minutes. Yeah, do with that information what you must. So what is the issue here? Because we could be talking about automating security monitoring as just a cool tech talk, but there is issues that is, I would say, arising, but it's very prevalent, and it's been increasing lately. And to explain what the issue is, we sort of need to go and explain how security monitoring works. And by the way, all the background graphics are mid-journey created by myself, so I hope you like them and hope they're not too distracting. But yeah, security monitoring, we're going to go into detail later, but basically someone does something somewhere on a computer or network appliance, whatever. This generates logs. And logs, for people like me, we love logs. So we will have some hypotheses about, oh, if something bad happens, it will look like this. And then we generate that as a search. So we search the logs and we generate alerts. And then we handle those alerts. And this is fine. This is how security monitoring has been working for a long time. But the issue arises when we start getting more and more alerts. And this is still fine, but once you start going over a certain threshold, you're not fine anymore, and suddenly you're scrambling. And this is the issue. This is something we call alert fatigue. And it can be drawn parallels to something like working at a help desk and you get 100 tickets each day, and you can only solve 20, so your backlog is growing by 80 each day. But instead of the CEO forgetting to plug in his monitor, this could be someone actually breaching your company and ransomwaring your entire set of data, which is not good. So how did we end up here? It's important to look at. And it has to do with perimeters, and it has to do with zero trust. And if I were to force one of you at gunpoint, don't worry, I don't have a gun, to tell everyone what zero trust actually is, anyone feel comfortable raising a hand? I'm not going to make you do it, but anyone know zero trust? Like, okay, that's good. It's a security conference. It's more than usual. But zero trust is something that everyone talks about, and when you ask people to explain it to you, not a lot of people can do it. And I'm not going to explain it there because it's not complex in that sense, but it has a lot of more things to it than people think. But people always boil it down to this: never trust, always verify, and then they never understand why. And the reason why, obviously, is because we need to assume breach. So we need to assume that someone is already in our networks doing stuff. This wasn't always the case. So this is another mid-journey image, but imagine this is a village, and we have this squared box around it. And this is how people still operate, but a lot of people used to operate, network-based perimeters. So we would say, this is our organization. Here are my entry points. These are the firewalls, and I can control the ingress and egress. So I know everything that's going in and out of the network. So I can say inside good, outside bad. And now this doesn't work as well anymore because we are coming in from hyttekontoret. For those of you who are not from Norway, I can explain that later. But we are working from Starbucks, Bali, being digital nomads, doing whatever. We have moved to something called identity-based perimeters, or resource-based perimeters, or object-based perimeters. And the reason for this is that we can no longer define our companies by these square boxes anymore, because we don't control all the nodes, the network nodes where people are working from, because they are working from home and from other places, and we're using cloud providers, we're using SaaS services. So it's impossible to sort of like draw a line and say, this is mine, because everything is everyone's in a sense. So what does that mean? And it means that no longer, for security monitoring, it means that the focus is no longer on the fence. We're not looking strictly at who gets in and out just on network traffic. We are looking inside and outside. We are looking at threat intelligence. We are looking at all the tools inside. We are looking at all the resources. And so a VM, we might be looking at endpoint detection and response. We might be looking at network, RBAC. We are looking at identity providers, and that's just a VM. So this means there are a lot more different signals, because if you've seen one firewall or NetFlow log, you've seen them all. They're quite homogeneous, but now we are introducing more complexity, because me and our security analysts, they have to know all these different signals and tools and how they work and how they fit together in order to protect. And this introduces more complexity that we need to deal with. And this just leads to more alerts and more false positives by nature. So to summarize it, I've stolen a slide, thanks Microsoft, from the Microsoft cybersecurity reference architecture. And some of you, you're here, you're brand new, you're just in the cloud only, very good. Our SOC is cloud only, so we don't have any servers at all. So we're quite lucky in that sense, but it's still quite complex. But then you go into companies that have been around for a while. So my company as a whole, we have a bunch of these current and aging servers lying around. And then if you go to something like banking with mainframes, or you go to oil and gas and OT, you have all of this. And the attackers that are attacking us, they don't care. They will attack anywhere. And this forces us into end-to-end security. So we need to think of everything. And not to mention, if you work in different industries, you have different regulations in EU, USA. It's different regulations. Obviously, threat actors are going to take all the tools and run with them. They don't have a conscience, so they will just use whatever when they can. And then not to mention the security tools. Just inside the Microsoft stack, there's like 1,000 different defenders, and they confuse me greatly. And so if you take into account that different companies will have a tool set that is from a lot of different companies, it's very complex. So to summarize it, 2 reasons why this is important to think of automation. First one is people. And I know from myself, and I know my boss isn't in the audience, so I would be comfortable saying this anyway, but I can't self-motivate by creating shareholder value. That's not something I can do. If the task is boring and I'm doing it every week, yeah, that's not something for me. But a lot of time people will put off automation because it has a high cost in the beginning. You have to be less effective for a little while to get over the hurdle and implement automation. So I created this slide. This is not based on any facts. This is just feelings and experience. But my idea is that it's not only time invested versus time gained. Because a lot of people will say, yeah, you're using 5 minutes on this task every week, and then you spend 2 weeks automating it, and then in 30 years we'll have made that time back. It's not that simple, because you still have to dread doing the task, remember doing the task, do the task correctly, and not fuck it up, because then you will have to spend time troubleshooting it. But also, if you have the person who is doing the task automate it, they will learn a new skill. They will be faster next time they're automating something. They don't have to think about actually doing it anymore. So my idea is that their happiness will go up. But yeah, this is just based on feelings. But people is the most important thing, because if you have happy people working, they're better at what they do, is my theory. And the second one is alert fatigue makes us blind. So if you have 1,000 incidents each day, you have turned on every detection possibly known to mankind. Yes, you will detect every threat, but can you actually see them and do something with them? Because if you see, what you're really doing is you're just helping the incident responders who are helping you with your ransomware find the artifacts 3 months down the line. You're not actually detecting anything. So in summary, and this is not the end of the presentation, by the way, automation helps cover lack of senior personnel, because some people have mentioned it already in their talks, but there is a lack of, like, we're talking about lack of IT personnel, and especially senior, like, skilled workers in this area. And if we're giving our juniors a bunch of, like, really easy, repetitive tasks that require no human input, how will they grow, right? And it also helps defeat alert fatigue. So this is the sort of focus of the presentation. The agenda on slide 22 or something is going to be words and phrases. For those of you who don't work in security monitoring, I will be explaining some of the phrases I'll use, so nothing is lost in translation. I'll explain security monitoring, how it works. We will look into data and detection, because it's also an important part, and then we will do, like, run into automation with some with a breakdown. I will use Microsoft Sentinel as an example, so I will introduce it a little bit, and then give you some examples, ideas, hopefully to trigger you, and do a summary at the end. Now, everything I talk about here today will be related to security monitoring, because that is what I work in and what I know. But a lot of these things have parallels to other areas as well. So it's not purely for security monitoring, but that is going to be the medium in which I share it. Yeah. I've timed it out to be like 50 minutes, but I have the tendency to get nervous and talk a bit faster, so it might be done quite quickly, but we'll see how it goes. Words and phrases. So the first one, probably a lot of you have heard, is SIEM, which is Security Information and Event Management. And what this means is this is where all the data goes. So this is where we take all the logs, we gather them, we parse them so they're searchable. Then we have detections or use cases, or they're called a lot of different things, but this is an hypothesis about an activity being malicious expressed as a query. So this is how we detect bad stuff, by searching the logs in the SIEM tool. And then when we get a hit, when we find something, we get an alert, or after a certain threshold, it's turned into an incident. And this is the output from a detection, and this indicates bad stuff, potentially, because it could be a false positive. And then we have SOAR, which is what we're going to be talking about today, the star of the show. This is a mouthful: security orchestration, automation, and response. And this is how we automate alerts and incidents. And this is basically when we get an incident, what can we do with it? Can we group it with other incidents, do enrichment, forwarding, response, and things like that. And last and least, it's ITSM, IT Service Management, which is where we send the tickets. So a lot of you probably know, like ServiceNow or Jira and stuff like that. And we use this to have a singular queue that we send cases to be handled by humans, so we have one queue based on severity. But this is not a requirement at all. So, oh, I'm way faster than I thought I would be, so that's nice. A little introduction to security monitoring and what we are trying to do. And in reality, some people have a little misconception that because in a lot of places the security monitoring team and the security team is the same. And so I work in a pure security operations center, so we are not the security team. So the security team will try to establish security like defenses and protocols and features to keep this guy out. And we are then just trying to keep this guy from actually stealing your stuff by monitoring. So we are not enforcing, but we are trying to make sure that we are living up to zero trust. So we are gathering logs, making sure that no one gets past the defenses and that we have visibility when someone actually does, so we can stop them. We do this by gathering logs. And so this is how it works. Again, someone does something on a computer, and this could be a cloud service, this could be a network appliance, whatever. It generates some sort of logs. And we will take those logs and send them to a log server via an agent, API, whatever, to the CM tool. In my case, this is mainly Microsoft Sentinel, but something like Chronicle for Google, IBM QRadar, Splunk, whatever your flavor, it works the same. The data is parsed into tables or whatever you call them, but this is basically just a searchable representation of the logs. And then we have the detection, which queries the tables and generates alerts and incidents. And then the incidents are then handled by automation, and it can be sent on to ITSM tools and the like. And so this is very, very high level how security monitoring works. When it's represented like this, it looks very simple, but there's a lot of moving parts in here. For our analysts, how they work with it is they will pick up a ticket from the queue, and then they will go to the CM tool and do some more work with it. And then if needed, they will go back to whatever tool or thing created the alert in the first place. So tools like Sentinel-1 or Defender for Endpoint. Some key components. So this is going to be like the data portion. This is the data we take in. This is going to be the detection part, and this is going to be the automation part. So the first key component is going to be data. And you can't do very much about data. The only limiting factor here is going to be money, because ingestion costs a lot of money. And that's at least the case in cloud-based security monitoring tools. They will skin you alive for every last drop of cash you have. And this is to be expected because it's a cost-value thing. But one thing to keep in mind if you're starting security monitoring is that you might want to cover the most important parts first. So work from risk. What is my most likely things to be hacked? What is the most devastating? And start there. A lot of people from experience will enable everything and then spend hundreds of thousands of dollars each month in log ingestion without utilizing even 10% of the data. Detection, and here there's an interesting trend in detection, and this is part of the problem. Anyone seen this movie? A couple of people. So it's just the title that I'm worried about. Everything, everywhere, all at once. And this is very true for Sentinel deployments, but we see it as well with other CM tools. There is a big community surrounding these tools, and they generate very good content. But this content is then taken into scripts and deployed en masse. So they're deploying everything, say 500 different detections, and then they're like, yes, now we can detect everything that's ever happened and will ever happen. And what's happening is you're getting 1,000, 1,500 alerts each day. You have 5 security analysts. How are they ever going to get through all of that? Automation will help, but you need to factor in some other things. And I will give you an example. This is me, a normal, non-vagrant kind of guy. I RDP into one server, then I disconnect and RDP into another server, like a normal person. And then you have this guy, another person, not me, who is RDPing into one server and then just RDPs from that server into the next one. This might be a jump host, but usually it's not. And this is something we like to refer to as RDP nesting. It's something attackers do to pivot laterally in your environment. And if your IT team or someone does this as part of their normal usage pattern, then detecting RDP nesting will lead to a lot of false positives. So deploying template detections, in this case, is a bad idea because it will just increase the number of false positives. And this is the same for every single detection you might want to deploy. You need to actually think about and tune it to fit every single environment, every single organization. So that's the detection part. Now for automation. And automation in general, and this is going to seem really simple, but it's not that simple, but it's actually pretty simple. Doesn't make sense, but it will. Automation is as simple as finding a repetitive task, pick one that requires little to no human input, at least in the beginning, and then automate. That's it. So this is a user interaction. A user finds a bug. Now, this can be in an application or in themselves if they go to the doctor's office, and then they're required to create a bug in a board. That's too many B's to be comfortable. But or if you can go and tell the doctor, I'm sick, I need help. So you book an appointment. And then the appointment is created or the board item is created and you go to solve the bug. So when you get to the doctor, you've booked an appointment and you said, I'm sick, I'm coming in. But the doctor isn't able to prepare. He has no idea what you are sick with, what are the symptoms. And the same goes for if you've ever, I participate in some open source projects, and some people will just say, this is not working, and then give you one line of code with error message, and nothing else. And it's like, what am I going to do with this? We have a template here that says everything we need from you, screenshots, logs, everything. And then you end up in a long discussion with the user about what is actually going on. And so this is the same with doctors, where they have no time to improve or prepare themselves. So what we did, this is just locally, not like a GitHub way, but when someone finds a bug in our stock, they have to go to a form that has a bunch of required fields that forces them to think about some of the things they want to say to us. And some people will just fill in not applicable, but it forces them to think. And helsenorge.no, which is a Norwegian platform, has also done the same for doctors, where they now force you to say, what are the symptoms? What have you tried in treatments for yourself? When did you notice it first? So you have a bunch of things that even if you were doing it anyway, you're now forced to think about doing it. So that's the idea here. You're forcing them to actually think about, maybe I should give this information, trying to guide them a bit. And so we can have an automatic process that picks up the submitted form and then creates the board item. And hopefully, this time, it has the information you need. So, SOAR, Security Orchestration Automation Response. How does it look? There are a bunch of different flavors. The first one is orchestration, which is going to be things like forwarding an incident to another system. We have enrichment, which is very popular, which is going to be when an incident comes in, we want to maybe check out a URL or an IP against an external or internal API. So we can do that and have it as information in the ticket. And then there is response, which is the least utilized one, but it's something like, this computer has malware. I want to isolate it and also add that as information in the ticket. And then if you've ever worked in service desk or security monitoring with multiple tools, you know that when you close a ticket and then you have to go back here and close the incident, and maybe you have to go back to another tool to close the alert, that's annoying. So we also want to add that as a part of our automation flow to have like bi-directional syncs. So this is going to be what we're going to be talking about mainly, and I will show some examples of some things you can do. We're still good on time, perfect. I will use Microsoft Sentinel as to give examples. So in order to do that, I need to explain what it is. So it's a cloud-based CM and SOAR solution. It's based on a log analytics workspace. And for those of you who don't know what a log analytics workspace is, it's a Azure resource that allow us to take in data, sort it into tables, and then do stuff with that data, like creating dashboards or having alerts. And there are some services that live on top of it, like Microsoft Sentinel. Data here, so it's another shade of gray. That's interesting. Not sure why I did that. So if you remember the earlier slides about how data flows in Sentinel, it's you have a data source, computer, Defender for endpoint, whatever. You're connected to a data connector. And the good thing about data connectors in Sentinel, for the most part, is that they have parsing built into them, so you don't have to do it. So working with a lot of previous Splunkers who thought this was amazing. But basically, this is how it works. It takes the data source and then sorts it into one or more tables. And then this allows us to democratize data. And so we can have a bunch of tables, which Microsoft Sentinel has access to all of them, that lives in the log analytics workspace. And we can have a user or a group gain access to one or more tables when they need them. So that's really good. For detection, similar to what I said, it's called analytic rules in Sentinel, but they can query one or more tables and then create alerts from it. The query language here is Custo, which is used in Azure Monitor and stuff like that. It's, if you've seen the query language before, it's not that, I was going to say special, but you've seen it before. So just thought I'd mention it, but we're not going to get into that because I'm not even the best. There's 7 people in my team, and I'm not even like top 5 in Custo in my team. So I'm not going to get into it. But detection, we have an analytic rule, query a table based on some idea we have that something is malicious. This creates an alert, and then at a certain threshold, an incident. And this is what we're going to be handling. So automation in Sentinel comes in 2 flavors. The first one is automation rules. And automation rules is very simple. If you've ever been into programming, it's if-then. So you have a condition. If it's true, you do something, and if it's not, you do something else. And then you continue down with several conditions. So imagine the title of an incident contains brute force. You can close the incident because what can you do about brute force? Or you can do nothing and then keep on going. They look like this, and I realize it's a bit tiny, but bear with me. It has a trigger, so the trigger is going to be what sort of like triggers it. It's bad to explain a word with the word you're using, but yeah. This is going to be what triggers it. And then you have a bunch of conditionals, which can be either and or. Yeah. And then you can do a bunch of actions based on whatever you want to do. And then you see here it's quite limited, so it's not very like in-depth automation, but we can start playbooks, and playbooks is going to be the next part. That's the more advanced form of automation. These are Azure Logic apps in underneath, for those of you who know Azure Logic apps, but this is a low-code Azure resource. Playbooks, they are very similar to Lego Robotics in that it's a big library of actions and triggers, and then you have a trigger at the top, and you drag a bunch of actions into the sort of like flow you want. You give them some input, and then you set it to run. You can sort of see the similarity. But here, just as an example, you have an incident that happens. Usually this is an automation rule triggering. You can create a record, post a message, and then you can send an approval email. And if they reply to the approval email with block user and IP, you can block the user and the IP. If not, you can just close the incident in ServiceNow and say it was error, false positive. Yeah. So some concepts. This is the trigger, as I mentioned, and this is the action. The action will take some input from the trigger just to refer to the right thing. And then you can add in your own stuff, like this is an automated comment. There is a bunch of actions, so we're not going to go through all of them. I've called them automations or operations, Jesus. But these are basically just a bunch of actions grouped together in like a family. And then you have a bunch of different ones, like actions inside this again. So what you're seeing here is basically just one provider, and then you have a bunch of different options inside it. So this is the point. We're at slide 70. This is the point where we start to talk about some automation examples. So we're going to talk about enrichment. And enrichment is something you do with entities. And entities are data items that are categorized and known by your security monitoring tool. So these are some examples, but it can be a username, host, IP address, malware family, whatever. And this is important because this allows us to take these items out of the data and use it for automation. So one example of this is a simple URL lookup. And this is something most security analysts will do if they get a URL that looks little bit funky. So you have a URL entity. In this case, I've gone with google.com, which is very malicious. And then I've said, I want to query VirusTotal and let VirusTotal tell me what it knows about this URL. And so I can take the result here and say, if the URL is malicious, I want to add a comment to the incident and say, we found that this URL is malicious. And if not, I can also add a comment and say, it wasn't malicious, or I can just do nothing, because then it's not important. If we build on this a little bit, hands off if you've heard of threat intelligence before. Everyone's probably heard of it. Okay. So threat intelligence is, it comes in different shapes. So I will explain what operational threat intelligence is. And this is, you're working with something called indicators of compromise, which are going to be IPs, URL hashes, emails that are known to be malicious. They're used in some sort of attack. So we know that at some point they've been malicious. They have a lifetime, but we share these indicators together. We, as a security provider, we work with a lot of different certs, a lot of other security providers, and we share these indicators between us to help fend off attackers. If there is a phishing campaign going on, maybe NF-cert will detect it and send us the indicators so we can stop them before they go anywhere. So we use a platform called MISP, which is Malware Information Sharing Platform. And MISP has a bunch of these events. And these events contain indicators, which are a list of IPs or URLs, and they're malicious. We know they've been used in attacks. So if we find that one of these entities in the incident has a threat intelligence match, we can say, we want to change the severity, we want to increase the severity, because then we know at some point this URL has been used for something malicious. So it's better to not take the chance and think that it's been sorted back into the IP pool or the URL is now used for legitimate purposes. So this is one example of that. But you can do this for a lot of different entities with a lot of different tools. It's just what you want to do. This is based on, I guess, how far you are and what tools you have, because something like, I'm not going to Alien Vault, if anyone's heard of them, they have a threat intelligence feed, which is free, which comes with a lot of true or false positives. There's a lot of data there that is old, and it will gain you nothing but alerts that have no value. So it's important to know your sources. In this case, it's our own curated MISP, but if you're using open sources, it might not be as good of a flow. Identity-based lookups are quite interesting, because if you work in a company, you have an idea about who is in the leadership, who has an admin role. So you can say a user entity, in this case, Filthy Rich. You can query enter ID, and you can say if the user is in the VIP group, or if the user has a certain risk, or if the user is in the admin group, we can increase the severity, because if it's an attack against a C-suite or an admin user, then that might be more severe than attacking Mark in marketing, because he might not have the access to do very many scary things in the beginning. Yeah. Okay, so that was enrichment, and there is a lot of different things we can do there. It's just imagination that sort of stops you. One thing to be wary of when it comes to enrichment automation is that we have created a lot of automation flows for our analysts that they have asked us to remove. Because we had an idea that, it's good to query every URL against VirusTotal. That's a very good idea. and then they will use different tools, and they will only query some URLs if it's in a phishing email or something. And if it's these types of alerts, the URL isn't important, so they won't query it. And so the information is useless and it's just information overload. So it's very important to which we have learned, to talk with your analyst, which are your customers after all, and actually pay attention to what they what they want. Yeah, that's something you learn as you make mistakes. So next one is going to be orchestration, and this is a very simple one, but this helps us combat alert fatigue and help us get more done very efficiently. So we have an incident, and we have this title: hack tool detected on endpoint. We can go to Sentinel and we can say, inside a certain time frame where we have the similar incident with the same host and the same title, we want to group those incidents together. And there is a lot of duplicates that happens. And so the idea here is that we have, these are all similar incidents, and it could be 500 of them. And we can have 2 of them happening inside a time frame of 5 hours with user X, and then another bunch of them happening with user Y. And here we can splice these 2 together because they are the same incident, basically, and handle them as one and do the same here. And this looks like a gimmick because it still happened 2 different times, but it's going to be the same handling process. But instead of doing it twice, we can now do it once. And this saves not only time in investigation, finding out it's a duplicate, but it also saves a bunch of time in writing the comments, closing everything. So it's a good it's good practice to do it like this, I think. And this scales very well, but it's very finicky because you need all the entities to be similar in order to confidently group them together. Okay. And then we also do a bunch of this, automatic closing or tuning. So we have this thing called malware was prevented. This is from Defender for Endpoint. And if malware was prevented, this means it didn't run. Do we need to do anything about it? And so we've said we want to close them. And then you can say, but can't you just turn off this alert to begin with? And then we want, no, because we still need this information for a correlation later, but we don't want to solve this incident on its lonesome. So we will close a bunch of incidents immediately, but if they are correlated into other incidents later, and correlation means that they are so similar and it's related, so they are sort of like put into a box next to the incident that says these are the correlation entries. We rather handle them there because then it's a part of a bigger thing, but a lot of users will just randomly download malware without even being phished. They will just go to a website they think looks very interesting and download some software, install some malware, and then that's the entire case. Defender will block it and they will be like, huh, interesting. Last, and this is more for keeping track of things, but tracking state. So we have an incident, and we want to send all incidents to the ITSM solution. So we can tag them with this tag when they've been forwarded. And if the tag contains forward ITSM, we know it's already been forwarded. So if we want to run another automation flow and send it to here, we know that this has been forwarded to the tool already, so we don't have to do it, we can just update it. We don't have to create it again. And so we can use a bunch of these tags to see what has happened to the incident already. And this means that we can take this into our other automation flows and say, okay, this has been done, we can skip doing this, we can do something else. And so this is just an example. I just created an incident just for fun. But this is very important if you get very into security monitoring because you will have a bunch of different flows running. And so it's important to know where it's at in the world, I was going to say, but where it's at in the sort of like downstream of the flow. Now, AI, finally. We can generate close comments. And this is something AI is very good at, because what does AI powered really mean? Powered by AI. We had a request from someone in our management to give them every single sprint, they wanted a full list of all the issues and user stories we were working on, and they wanted it in natural language, and they wanted it explained to them. And so what we did was we generated, we found a way to write our user stories so we could just send it to OpenAI and have it generate that summary for us. And then my closest boss was like, so this means we are now powered by AI. No, it doesn't mean we're powered by AI, it just means we use it a little bit. And it's just like, it's not even a part of the security monitoring flow. So, but here is, we close an incident, and every time we close an incident, we want to have a close comment, because if someone from our customers want to go in and check what's been done, we need to have like a very short, concise, like, here is what we've done to this incident. So you have comments from the analyst, you have what actions have been taken, you have the description, and we want to take this all, because this is already content that has been generated by a human, and so we can say, and this, if there's any budding or experienced prompt engineers, please don't bury me alive over this. But so you can take all this information, you can tell it what you want, and then you can have it summarize it for you. You can summarize it twice, like sea level, or you can summarize it very like technical and concise. You can do what you want, but we can take this and send it to OpenAI, Azure OpenAI, or whatever you use, if you use Bard or whatever, and then you can have that summary added as a comment. So one of the things that is the most like time inefficient is generating close comments, because you're basically just taking everything you've written and trying to generate a neat summary. And this is something humans are decent at, but OpenAI is very good at. So this is a perfect use case for AI in a security monitoring flow. And then we have response, which is going to be something like, because most of our customers are big to the point where they have 24/7. We are 24/7, and they also have some contacts which usually are 24/7. But what do we do when we are a small, medium business or something, and we don't have people to work after work hours or office hours? So we want to check the time, and before 5, if you start working at 5, you're sick, and I love it. But if it's false, we can stop the flow. If it's not, if there's an incident and we are at work, we can handle it ourselves. But if it's true that it's outside office hours, we can check if the entity contains a host, and we also want to check that maybe the incident has a certain severity. We don't want to isolate, like, this is an informational alert, this host has turned on, and then you start to isolate everything. But we can then just have flows that automatically isolate the computer and add it as a comment as well. We can do this with users as well. If a user reaches a certain risk, we can automatically isolate them or disable their user. And so these flows are very useful if you have limited resources. And then you also have to be aware that, yes, you might stop something, but you might also break something when you're doing this. Ah, the hours changed. That's interesting. So you can do it inside office hours as well. So you can append this by just making one simple change. So you can have this in Slack or Teams. I'd prefer Slack, but we use Teams. But you can say that if it's inside office hours, we want to get an approval message in Teams, and then you can click yes and then isolate it from there instead. So you can have a built-in flow there. This is something else entirely, but just as an example, you can have adaptive cards in your flows, and you can take the input in the adaptive cards, and then you can do stuff with that. So this is update severity or close incident, and it looks like this. So you can just, usually you don't want to do it based on only this information. You maybe don't want to do it, but you can imagine doing this for just isolating one computer, right? So it's, yeah, it's this is, it's again, what you need, you can build mostly what you need. So if you have a need that needs to be covered, you can build it. It's only like fantasy that's stopping you. All right, so this is going to be one last example, because a lot of the things I've been talking about has been inside Sentinel. So today I'm just going to show one simple example in Azure DevOps. I write in PowerShell, so for those of you who want to boo and leave a red note, you can do it, that's fine. But PowerShell allows me to do a lot of things I can also do inside of a playbook or a logic app. But I can say if I want to generate a summary for all of my sentinels instead of just one-on-one incident. So I can have a pipeline that runs PowerShell, and this pipeline I can point it to all the different workspaces I have, and I can say I want to look at all the closed incidents the last 30 days, which are a true positive, which means it was an actual security incident. I want to take this information, add it to a variable, and then generate a summary based on that. And here as well, we can use OpenAI, because OpenAI is very good at taking data, and if you're being strict with it, then it can take that data and generate a summary. So we can have like, these are the trends we are seeing across all of these different sentinels or just one workspace. What are the true positives? What happened? What did the analyst do? And you can take these reports generated in Markdown as we do or PDF, and then have them sent to. So this is we have this as a analyst flow, so they can start it and they can say which workspaces do I need it for, how long back in time do I need it for, and so they will get the report sent to them on Teams. But you can do it on mail or just upload it as an artifact if you want. So this is just one example flow there. This brings me to the end, just to try to summarize, because yeah, what were we really talking about? Automation is quite neat. It saves us a lot of time, and just as an example, time adds up. When you're handling an incident, some things you need to do, it takes a certain amount of time. If you're experienced, it takes less time. If you're not as experienced, it takes more. I just made some examples here. A normal incident can take longer than this. It can take shorter than this. But this is just an example. One incident, and then if you change a little bit without automation, maybe it's shorter. So I made a calculation. Let's say we have spent 3.5 minutes on things we could have automated per incident. Now we have more than, but let's say we have 10 analysts. We have 20 incidents that they handle daily. It's a lot more, trust me. And then they spend 3.5 minutes on enrichment and doing things that we could have automated. This is 700 minutes or 11.5 hours per day wasted for 10 analysts. And so if you add this up, this is more than one person's amount of work. And a lot of incidents, they will waste way more than this. So automation is very helpful in saving time and combating these issues that we're having there. I brought back some Minecraft in case you're starting to lose interest. It saves us from a lot of intangible time usage. And this is going to be things like, if you know you have to do something over and over again, you're like dreading to do it. It also saves us fucking the task up, doing something wrong and getting like errors, and then having to spend time fixing the error. And then it helps combat alert fatigue. Just because you can use AI doesn't mean you should. A lot of these flows, they are fine without including AI. We don't have to put AI in everything, but it's good for some purposes. Lastly, if you've gotten anything out of my talk from today, it is that, or hopefully it's that, there's a bunch of things we can do with automation. Yes, it will take some time to get into, and it will spend a lot of time in the beginning to start. But hopefully, if you get into it, you can, instead of, we have a lot of things in my company. We are a consultant company. So we will go in and we will say, we can automate this for you. And if you do that, yes, that flow is fixed. But for your teams, please try to teach the people you are helping automate something to automate, and let them do it themselves, or let someone just automate their own stuff, because then they will know how to fish. This is just, the GIF is to symbolize teaching a person to fish, and then they know how to fish, and now they can teach other people to fish, and so we can have more people automating. But it's also a magic harp, so there's that. That was it. Yeah, we have 10 minutes left. If there are any questions, we can do them now. If there's no questions, then everyone can move on with their day. Thank you.